The last session of the afternoon, and this session is on a panel discussion. Okay, so we've already had our keynote ready, and we're going to have a panel discussion with some of the keynote speakers, and it's going to be talking about opportunities and challenges in big data and social computing. And the moderator for this panel discussion will be Zhang from Beijing University Post and Telecommunications. So I'll hand over to Mike to Zhan to be able to start.
Okay, so the next 1 hour, we would like to invite all 5 panelists to show their ideas about the opportunities and challenges in big data and social computing. And before that, I would like to make a brief introduction about all the famous panelists. Okay, the first one will be Guanling Chen. So Professor Guanling Chen is an associate professor of computer science at the University of Massachussetts, Lowell. He is also an affiliate faculty at the Institute for Security, Technology and Society at Dartmouth College. After receiving his bachelor in computer science from Nanjing University in 1997, he completed his PhD in computer science from Dartmouth College in 2004. He was an I3P fellow before he joined the faculty of UMass Lowell in 2005. His research interests include mobile computing, ubiquitous and pervasive computing, human-computer interaction, and intelligence systems. Let's welcome Guanling Chen.
Thank you for the introduction. So I don't have a slide, so I'm gonna just open my talk regarding a application. So I'm a application person. I'm really an end user person. I focus on the user side of the story. So let me talk about one application I and my collaborators are working on to address a very important problem in our society. So here is a number. So in the United States, every 100,000 people, there are 10 people who commit suicide. In China, suicide, yes. In China, the number is 23. So actually, the suicide rate in China is higher than the United States. So many people commit suicide because of depression. And that number is much worse. So in the United States, every 8,000 people, one of them has depression. In China, that number is 3,000. So every 3,000 people, there one person has depressive symptoms. So the traditional way, how do we treat these people, right? So usually when problem occurs, right? So when they had a problem, their family members or their friends get them to the hospitals, or when they actually start to commit suicide, or that's the contact happens, that the doctor will see them, the counselor will provide help. And then they see the doctor, then they go back, and then no care will continue after they left the facilities. So now here comes the technology challenge. Can we provide continuous care to this population? Can we sort of provide a real-time monitoring and the prevention or even predictive system to know that they're likely have worse symptoms and need intervention right away? So there's some work actually starting from the social media. There's a paper from Microsoft Research. They analyze people's Twitter feeds, and later some other people analyze Facebook feeds to predict whether that person is depressed or not. Right? So, understandably, when people are depressed, their behavior changes differently. And so I think 2 years ago, there's one girl from Nanjing actually committed suicide because of depression. And her Weibo account actually has updates that has predictive power that she might be depressed and need help.
So this is kinds of opportunities for the big data.
Right. So we for this real applications, we do have a real problem that needs to be addressed. However, my approach is a little bit different. That we start from the smartphone monitoring because people carry their smartphone 24/7 and it's always with them. And again, when they start to have symptoms of depression, their behavior changes significantly. So what do we monitor on the smartphones? So we monitor their usage. Are they playing games? Are they using Weibo, Weixin all the time? Or does the pattern change? And also their mobility, right? So do they move to the places normally? Do they go to work at the same time every week? And also their sleep patterns, right? Because when people sleep, their environment changes, such as the light exposure and the sound. So there are a lot of sensors in the smartphone that can provide streams of the data that can help people to monitor this particular population. And that's the great opportunity for the big data research and also the social common research. Because when people is depressed, their social ability, their social interaction changes significantly. So this is a good opportunity and good challenge for us as well, because the data is very noisy and there's no general model because everybody behaves differently. So you have to derive some kind of baseline to get the individual model for this population. So I just want to point this problem out and hope some of you will be interested to address this. Thank you.
Well, thank you. Next will be the Professor Chunming Hu. Dr. Chunming Hu is an associate professor and the vice dean of School of Computer Science, Beihang University. He got his PhD degree in 2006 at Beihang University also. His research interests are distributed system, software middleware, system virtualization, and resource scheduling in the cloud system. And let's hear about his opinion about the opportunities and challenges in big data just after his keynote speech.
Thank you. I think I have talked too much. So, well, I just try to make it short. I think the key point of we are talking about the opportunity and the challenges. So, opportunities, big data is a big value. So there would be lots of focusing both on industry and from the academy. And I think in my talk, I talk about the challenge is, so I think two key issues is big data is crossing part. So not only the crossing in computer science, but also the crossing between some other application domains. So I think this is the opportunity and also this is a challenge. And another thing I would say, I agree with you mentioned about that we in big data, most of the things we need to do it more application specific, because application specific issues will give us more hint to make the optimization both on theory and on algorithms and also on distributed infrastructures. So this will give us more opportunities to make things good. So that's it. I will leave more time to conversation with all of you. Thank you.
Thank you. So I would like to invite Professor Zhan. Dr. Justin Zhan is the director of iLab. He is a faculty member at Department of Computer Science, College of Engineering, North Carolina A&T State University. He has previously been a faculty member at CMU at National Center for the protection of financial infrastructure in South Dakota States. His research interests include big data, information assurance, social computing, and health science, and he's a steering chair of ASE IEEE International Conference on Social Computing. And he also have some slides.
Okay, thank you. I have some slides. So the slide is basically I'm trying to use some of the recent work and on big data. I can do this. Yeah, I would like to introduce some recent grant that we have and from the United States funding agencies and talking about big data stuff. So I would like to focus on one of the step funding project called Data Bridge, and that's basically a social network for long-tail science data. So it's talking about data bridge, and we're talking about social computing, social networks, and so on. But what we want is we want to build up social network of scientific data, not human personal data, and so on. So that's the idea.
So what do you mean the scientific data?
Exactly. So that's called data bridge. And so this example here is show you some networks. You can consider this a social networks and so on. But we want to change this to be a scientific data social networks. So the goal that we have is trying to identify the dark data and from the long tail of science. Okay. So we talk about big data a lot. You know, this morning, yesterday, and different conference and different speaker talking big data. Well, where did big data come from? And a lot of big data coming from kind of long tail small data. Okay. So after you combination and doing this and accumulate it, and you become so-called big data. But meanwhile, from this long tail science of data, there's a lot of maybe communications or connections from different type of the small long tail science data. We want to find the communications. We want to find the connections and linkage from this. So this is the whole idea we have. And we want to find this to develop this to assist the scientists discover interest data set by automatically forming a community data set. Let's use example to show that's basically talking about National Science Foundation, and we have a friend who is a professor at Northwestern University in the United States, and he have a funding grant from National Science Foundation talking about doing research based on the National Science Foundation grant data. Okay, in 2011 from National Science Foundation at the United States, and 11,150 awards is given to all the researchers and so on. And media grant from there is talking about 126,500. And it's follow power law distributions based on their research. So data basically individually is not big, right? Based on the size we have.
Who follows this power law distribution? Or
The grant, the number of awards given to the researchers from, I say majority from the United States. And maybe it's some international grant, but majority from the United States. And then the median number of this grant is like this, and in this year, okay? And different years maybe follow up, looks like it has some bigger and smaller. And some of the research, a lot of research, right? This is 11,150 award. Let's assume at least 11,150 researchers. Let's assume one researcher getting one award, okay? So 1,000 researchers, okay? And primarily from the single investigator from National Science Foundation. So data individual is not big, but large in aggregate, okay? This is his research result. Let's just copy some slides he published. So data bridge strategy is trying to build a social network for scientific data, as we mentioned at the beginning, okay? So there's different challenges along this line. And so it's let's give me the summarized of the information about why we want to do this, the strategies, and the result as well. Okay. So we use the different strategies and to make this happen. To how do you link this long tail science data from different aspects? Okay. So we use different strategies. For example, data and worse networks and IROD networks. These are two big worldwide impact. And data science related projects. This one is led by Harvard University at Boston, and this one is led by UC San Diego Supercomputer Center. But now all the PIs moved to UNC Chapel Hill, and also the PI and co-PIs from different research proposals with us. So what's the strategy we use? We have to investigate similarities or connections. Right? You're trying to build something from the different type of and long tail science data. So how do you hook them together? Okay, you must have different strategy to do that. We have data to data connections, user to data connection, measure data connection, and different other new stuff we are really developing as well. This is original proposal for different stories. So this is again follow up the different different methods. We use strategies and for the similarity measurements and linkage and so on. Let's look at this slide, okay? This slide gives you kind of overview what's going on with this data bridge project, okay? So we use the DVN, the Dataverse Networks, that's basically hosted by Harvard University. They have tons of data. It's follow long tail science of data, follow this kind of distributions. And so that's open access so that we can get the data to do research. And also they are the partners for this project as well. IROD is kind of distributed and server management system used so many organizations and our government as well in the United States. So then after this, and you have a date and metadata gathering unit. Okay, this is from this different data set. And of course, this is only a sample data we have used, but you can use other data set like the Microsoft data, Baidu data, other data that you have. Then after that, we have tractors and metadata ontologies and base. Then we come to the fundamental part. It's called relevant engine, and basically that's engine for relevance. Okay, and we use different algorithms. We develop existing ones we use as well, relevance algorithms and social metric analysis as well. So after this, we try to build a networks. So this is kind of layered networks, and you can think of these networks, at the bottom level, and you have a lot of data from different domains and follows long tail sign distributions. Then you build up the layer networks, one layer up. And in the stream case on the top, you can consider this only maybe one node. Okay, those are examples. This node have a lot of parameters. Then depend your interest, you can look at, hey, this is I only interest in Baidu data, okay? Baidu research here. Then you can just click the Baidu parameters related stuff, go to next level, that may be 5 node, 10 node, 100 node, depending how you define your layered networks. So eventually trace back, and among this big different type of data, that only maybe certain part of data is your interest, okay? To address your research, academia, or government or business questions. So you only want to focus on those kind of data. You can run the database again until you finalize the data set can directly address the question. Now, what's the advantage doing this? Well, if you don't do this, and let's assume you have super computing powers and to calculate big amount of data networks. Well, one, you take a lot of computing power to do that. And more serious problem is once you analyze it, the result is full of noise. Okay, because you analyze this data, you don't know which are relevant or not. Okay, so that's a big challenge, right? So by running Databricks, you basically have this advantage. First, you save a lot of computing powers. You don't have to run all the data that you have. You just focus on data that's relevant to you. Okay, so you address the question.
Okay, you mean this data, so process the data.
Yeah,
it's kind of processed data. It's not the raw data.
Well, you have to process some data, right? And it depends how the interface between, next slide, depends the interface that you designed and between the data set and also the data gathering and a unit, then you have to make your data somehow follow this interface. Otherwise, they cannot talk, right? Okay, and formatting, those kind of metadata stuff, okay? So another advantage is, it saves a lot of power, and second, is more accurate, okay? The result for the decision makers is more accurately addressed the question you want to address, okay? By doing this, so this is a huge benefit. And I was invited to give a talk at White House last year, and they excited, okay? They said this is very interesting to a lot of industry and our government people. This is when you can finish this project, we can use this. So we have a first prototype developed, and we still doing the testings. And after that, we want to release for public use. And this slide, basically, each part have an interface. Okay, it's isolated. It's linked, but isolated in terms of this, modularity. For example, people working here, they can focus on here. Okay, so you have interface to this part. People working here, they can work here. They have interface. Okay, interface as well. In that way, we can have a multiple group of people working together. Okay, and you just worry about the part you focus on. For example, in North Carolina A&T, we are leading the computer algorithm, computing part, which means relevance engine part development. So pretty much it's a software and algorithm development part. Then eventually we have the visualization. Once you have networks, and we want to visualize. So visualization piece is part. This part actually is leading by UNC Chapel Hill. Okay, that's also important part. Okay, so this is kind of data flow programs, and that's follow up the previous slide. That's on my slide. Thank you.
Thank you. So the fourth one will be Professor James Chen. So Dr. James Chen is an associate professor in the Department of Electronic and Computer Engineering at the Hong Kong University of Science and Technology, and a visiting research fellow at the University of Cambridge. He is also the founding director of Asia's first social media lab, and spearhead multidisciplinary research and innovation in cyber physics social media system and mobile media broadcast systems. And so let's welcome Chen.
Thank you. Since Justin just introduced one project, so I'm going to introduce a few projects within a 1 minute video, okay? Thank you. So, actually, I just set up a social media lab actually back to 1.5 years ago in Hong Kong University of Science and Technology. So what I'm going to talk about my thinking in terms of the opportunities and challenge for big data and also social computing research by illustrating a few projects. There are several reasons I just want to stimulate every one of you. I think within these 2 days, we have been seeing a lot of interesting ideas and papers, like how do we deal with big data for some application, and also some social computing research that actually can help us to derive some analytics. This is actually just the beginning, I think, for the era of big data and also social computing. So in the coming 1 minute, actually, before I introduce, I just want to share with you my 2 views of my research philosophy, which is actually the dimension of the research in my research lab. So all my research students and also staff in my research lab, we do only 2 things. We do theoretical analytics for the data actually from conventional social network. What is conventional social network? Here we are, right? We get together. I personally don't see social media is new thing, but recently we make it so new, right? So basically we analyze all the data from conventional social networks, online social network, mobile social network, or even future social network. We want to understand some phenomenon. So we try to understand this phenomenon and then come up some analytics to predict some possibility on existing system. So that's pretty much the dimension in our research lab. So some of the project I'm going to show you in the video, not this advertisement, is around this philosophy. So the other dimension of my research lab is all building system. If you look into details, just like I mentioned, social network is not new. But what happened make us right now this day, we were so excited to do a lot of interesting ideas because we can have the access of data, right? I think social network research has been, I think, doing a great job by those researching in social science. Just actually 2 weeks ago, I have our lab have a co-event with Tencent because they set up a new internet research and also society research institute. It's actually bringing people from engineering, computer science, and social science people, economics people, or physiological people, right? So what I see in the future is because of the Web 2.0, we have the online social network. Because we have the smartphone, we're basically bringing social media so close to us, right? So you can foresee what's next, right? We actually have the new emerging sensing technology, computing technology, portable technology, or wearable technology. You can pretty much foresee the next social media will getting more personal, which eventually, I think, we're back to primitive. But this primitive, which is actually one of the areas right now I'm really active, I think, with Alvin as well. We're pushing cyber, physical, social computing. Why is that? Well, in the past, we have physical social network. And then later on, we have online social network. We're trying so hard trying to predict the correlation between online social network behavior so that we can predict physical behavior, right? Can we predict the gender? Can we predict your location, right? And then later on, we have the smartphone that give you a lot of true information about location. You don't need to predict my location, right? We're spending a lot of effort, but you have new technology right now already tell you exactly where we are, exactly the temperature, exactly the voice level, so we can even predict where's the environment this person located. Then what's next if I have a wearable device in the future? If my smartphone can interact with, for example, this projector, if you keep on collecting the material from this projector, I know what you like exactly. So I should actually gauge the advertisement automatically to match what you're interested. So this is what we foresee in our lab. So the other dimension of our lab, all my research students, they just build things without theory. They basically watch the movie from Iron Man, Minority Report, whatever, and then they just build it. Okay, they're trying to imagine what's next for the social media system. So that's pretty much I want.
Without theory, just to build things without theory.
Exactly.
Okay.
Well, the only theory is from the movie. Okay, because once you have a new system that allow people to interact with each other with the content, then we create another new things. We create another dimension of social signal. It's no longer just text or data or the emotional icon, because we try to show how to try to understand the mapping between the text and your emotion, right? But if I already have an image, if I have the Google Glass, I look at you, we can analyze not just your face, knowing who you are. I can even from your facial expression, I know your emotion. That actually already brings us to another dimension of the social signal, can give us a better prediction. Then maybe we can solve the grand challenge problem by our first few speakers talking about, can we predict the person going to be commit suicide? Because I can see from their face. So before I show the video at the very end, what actually we are propelling the challenge and also opportunity, I think is something catchable and can be imaginable. Why is that? I think we are excelling different analytics from all our great research results from the past, from machine learning, artificial intelligence, all the research we have before. Right now is a booming time because we have the cloud computing. So you can see some of my project. Actually, I just assume I have endless storage. I have endless computing power. I don't care about the storage. I don't care about computing power because we are just right at the convergence. Why big data is now, not the past, not tomorrow? Just because we are at the right convergence, right? And at the same time, we are shifting another new dimension that we feel that we are getting close to our primitive world, which is we call cyber-physical. When that is coming, what can we do? That means we can create a whole new world of research that is so close to what we want. When you walk out from this room, your phone will receive a message advertising where should we go for the dinner tonight. Oh, no, of course, we already know that, right?
Yes, we already know.
But we can actually make a message so highly relevant, right? Because we can know pretty much the taste of what you want, your location, without bombarding everyone with those noisy information. So this is just one example, and I would like to end my sharing by this video, and then you guys will have a better idea about what we are doing in Hong Kong University of Science and Technology. I don't know how to turn the volume.
It's audio.
Sorry. So it's a new research lab. We only have about 15 students, including staff. So you can see you have a picture in your phone. You can slide into a glass, and you can slide into the ceiling, right? So we don't need to put on the PowerPoint. Anything you see on projector, you can just grab it into your phone. And when we share pictures, no longer WhatsApp, no longer WeChat, just like a physical thing, you grab it and put it into other people's phone. When you look at direction, right, when we try to rush for information, we look for information, but in the future, the information look for you. And then we can actually direct to the people to the right location immediately. So when we deal with the big data analysis, we don't deal with text anymore. We just look into the pictures because the picture have 1,000 words to describe people, and then we connect people, or we can try to find out the connection between people from all this picture. And within that, we know the location of people. We can even predict the co-location or encounter between two people. And all these things you see, and the actor, they are real from my lab and all my students. All right, that's pretty much what I want to share. Thank you.
Okay. So the last panelist will be Li Mu. Mr. Li Mu is a principal architect of Institute of Deep Learning at Baidu. His research interest lies in machine learning and distributed system. He's also a PhD candidate at CSD of CMU, working with Alex Lowell and Dave Anderson. Before joining CMU, he worked for Baidu's AD teams and was a research assistant at Hong Kong University of Science and Technology. He got his master and bachelor degree from Shanghai Jiao Tong University. Let's welcome Li Mu.
Thank you. Hi, I came from Baidu. We care about the money. So, what our goal for big data is that we want to make value from big data. So, for our advertising application, we gain about I think 100 million of yuan each day. So, it's a single machine learning system, just using the ads displayed at Baidu. So, but this is just one application. We want to build many more applications, and we have many more data. So for this problem, there's three things I think very important. One is what is the data? What is the size of the data? So I think for big data, for the industrial viewpoint, is that we maybe cover billions of users. Each user maybe generate 100 to 1,000 of activities. So in general, we have 1 terabyte of data. So you have many applications. Each application maybe have 1 terabyte of data or more than that. So here's the data size. So given the data size in the few years, I don't think a single machine can handle it. I don't think the memory capacity is so large enough. So you just load the data into memory and write a MATLAB script and run it in a few minutes. In a few seconds, it's not impossible. So that is one key question that we want to have a very efficient system do not need the data scientist to write very C++ code, a lot of code to handle data. So we want to have
efficient or efficiency.
Yeah, efficient distributed system. So for the state-of-the-art system, maybe for the Baidu, we can run 1 terabyte of data. That is 1,000 of terabytes. Data is have about I think 1,000 billions of examples and 100 billions of features. So we run sparse logic regression. It's a simple linear model that using 1,000 machines can be finished in 1 hour. But such a system is really hard to write, and we cannot build every system for every application. So on tomorrow, I will show you a joint work with CMU, with Google, with Baidu, a public distributed system that can be scaling to the industry level problems. So
Scaling, okay.
yeah, scaling to that. So we can run the Baidu's data just using comparable to the Baidu internal systems. So that is one thing. The second thing I think is happening in the future is that instead of just using a big data feature engineer and run a linear model, we can run a very complex model. Because we have so many data, we can run a more complex model than what we imagined before. For example, deep learning. Yeah, that's very hot industrial. So some years ago, we do not run deep learning because the data is not enough. The system is not enough. We do not have so many computational power. But nowadays, deep learning can easily beat the other things. But in fact, deep learning is still a simple model. It's just a multi-layer neural network. So 20 years ago, we know that. But before these 20 years, we have far more complex models. And I think the future is that we can, using so many data, and we have supported by fancy systems, and we can run more complex models. I think that is my view. Thanks.
Thank you. So just we have all these 5 panelists for their 5 minutes up. So their opinion about the challenges and opportunities of the big data and social computing. And now it's time for the panel discussion. So do any of the audience have some questions to ask for some of the panelists or all of them, the panelists? Any questions from the audience?
have a question for Professor Chen.
Okay, wait a minute. For the microphone.
Professor Chen.
Okay.
Did you have any successful story to tell us about you can find some depressive guys?
To predict some depression.
Any successful story?
The short answer is no. Okay, so this is a very early study. The only study I know is done by a professor at Northwestern University. They have deployed this mobile monitoring for depression patients. Unfortunately, at that time, their technology was not very good. They have been using GPS to monitor users' location continuously, but it gave them a lot of problems. So they're predicting the user's mood. The accuracy is about 60 to 70%. So the prediction was not very accurate. So later, I think last year, there's a Mobisys paper is done by researchers at Microsoft and also Rice University. They look at how you use your phone. Basically, what kind of applications you use. They monitor
Still a kind of behavior research.
Yes, behavior research. Yes. So again, they want to use this usage pattern to predict your mood, right? So in their case, the general model accuracy is about 60%. But if the user continues to train the learning algorithm for 2 months, then the mood prediction can be 95%. So there's potential, but the training time is very long. I cannot imagine any person with depression symptoms were willing to train for 2 months, right? So there, I think there's the potential for different aspects, but we can combine them. Another study is by using the microphone from a smartphone. So, for example, it can hear what you're talking about, right? And when you are stressed, then your frequency and pitch will dispose, right? So you actually can detect the stress level by simply listening in the environment. But again, that's a very narrow sort of aspects of the depression, and also it consumes a lot of power for the audio analysis. So we are still at the early stage for this research, but I believe it's very exciting, and I think it requires system research and also the data analysis. At this time, we are working on small data, not big data, right? But if you imagine, right, with all those sensors, particularly the audio feed going back, and with large population, then the data accumulation can be huge. And if we can have a population-wide sort of mood prediction or the mood data, then I think it's a very exciting data set, and it can benefit a lot of research on the behavioral health, particularly for the mental health.
See, in this case, what do you think about the privacy of the patients, the security of the data?
Right. So far, the doctors working with us said they have been talking with the patients about the possibilities.
So you just make the patients anonymously?
No, actually, the patients don't really care about the privacy. Right, so the doctor,
you monitor us.
Right. Well, you are not a patient, so the patients actually never said, "How do you know so much about me?" Or say, why do you have so much information about me? So what they said is,
please understand more.
Yeah, so they said is, okay, you know so much about me because you have so much of my data. What more useful information you can give to me, right? So what a value I get. So one interesting statistic is about the wristband, right? So there's all these wearable devices. Like every 10 American, one every 10 American has a wristband or the tracking device. But more than half of them are no longer in use. And most people will stop using it after a month because the value is not significant. They don't really get much out of it, and they have to take the inconvenience to wear it every day. So I think the privacy is a problem, but people really care about the value. So if you give them the strong value, they're willing to sacrifice privacy.
So I would like also to give this privacy question to the data breach, the project. Have you ever considered, or I guess you must have some answers?
I have a microphone. Yes. I asked Guanling and follow-up question. You know what?
I thought you were answering the question.
Before answering his question, let me ask a further question, follow up his question about privacy. Because I have been doing privacy research quite a bit as well. And talking about the patient-related data, we always have the privacy involved. Even individual patient may not be, I don't care whatever depend. Like you answered, right? But you're talking about clinics and hospital, they have to care about it because they don't want to have legal responsibility. Right. So my question to you is, where you get this kind of data, without have a trouble with the privacy stuff from the hospital and clinics?
This is for the individual patients. What do they think? They said they want more values, right? It's not to say, I know there's a lot of regulation on the privacy and the security on the medical data, right? That's for sure, to protect the patient. But, if we look back at the history, the data sharing, right? If you have strong value, you see these stairs, right? So more value, you get more sharing, you get more value, you get more sharing. Look at where we are now, we're sharing all the time. So it's always, what's that?
We share all the time.
Right. So because we have a social needs, we want to connect with our friends. So that's why we share. Right. So same thing for here. We still want to have a system to protect the security. We don't want to unnecessary leak of the data. Right. But what I'm saying is the patients are willing to give the data to the right person if they get the value back.
So basically, you just directly plug from the patient itself.
So basically the doctors talk to their patients about this.
That's nice.
Right.
So how about you? How about the privacy problem solved in your data breach project?
Yeah, you know what? We have actually R1 from NIH and working together right now with UNC Chapel Hill and
NIH, okay.
And working with University of North Carolina Chapel Hill and Duke University in Harvard, and they have very strong hospitals and hospitals and medical schools, and so they have kind of a program and a collaborative program between these three universities and about the medical school. So basically, and they have the system that's have all the data from the hospital available only for small researchers that's agreed in a small group.
So you have some kind of agreement among all the participants of this project.
Yes.
And only the researchers there can use that data.
Yeah.
So it's not open.
It's not
data.
open at all, because we're doing this kind of research. They said, doing this patients related research, we have to have the data, right? And diagnostic data and so on. And they said, well, from maybe personal perspective, not a public one, we maybe share with you for this small research purpose, but we cannot make that public into the research and so on. So what we're trying to do, they want us to do to help them is trying to develop a kind of privacy preserving and data analysis systems for the patient data from hospitals. So we are actually working on together for this. We have some, a lot of research in the past 10 years about the privacy protections and application for data minings and machine learning, and some people even talk about deep learning, so, okay, and the privacy protection feature as well. Now we're starting to develop this for them, and that's why this is actually the current situation and we have for the patient-related data privacy protection. That's why I asked you the question, where you get the data, because we have a difficulty to get the data directly. They don't share with us. It's a challenge issue.
Okay. For our research, we recruit subjects, right? So if they agree on our RB, they are sharing the data
So
with
directly
us.
kind of patient subject.
Right,
okay, I got it.
We get the data directly from the patients.
Okay, I see. And I guess that's also create a difficulty for you to create maybe big data, because so expensive to really recruit the subject.
Right. So if we show that our system or algorithm can work and can actually produce value, then we have the chance to deploy it to a mass scale.
Good
right?
strategy. Yeah. Maybe we can also use that strategy as well in North Carolina.
Okay, so now Yeah, even the industry, even the Google announced that they are quite interested in the kind of the health-related research. So I guess it's one of the big challenge or opportunities comes from the health for this big data. Okay, okay, thanks for the thanks.
And so I have a question for our Baidu colleague.
Yes.
Yeah, I know. Since you come from the industry, right? My question is, what kind of a challenge in Baidu do you see in big data mining? And the second question is, what kind of important problems do you think we can do in academic research, but also important for the industrial problems?
You'd better to summarize your talk.
Yeah, I think the first question is what the challenge about the big data? So,
To Baidu.
yeah, for Baidu, two things. One is the money. If you run some program, you need to pay the electronic fee. So it's quite expensive. Every day we spend maybe 1 million of yuan on the electronic fees. And we cannot buy so many machines because we need to build a data center. We need to get some area from the government. It's not generally not possible. So
in this case, it's mainly a kind of economic problem instead of the technology, the problem, or the technical problem. Right?
This is restrict. This is a resource restrict. So we have a lot of data. We have a lot of application to run, but we only have so many machines. So this is the most question that you need to get your program runs very fast. You need to have a good implementation. You need to have a really good optimization method. Even you reduce the number of iterations, iterative algorithm for 2 iterations, maybe you save a lot of machine hours. So, and that is the engineer part. Okay, here is the application part. I think the most interesting part, research project, I think for me for the next year is multitask learning. That is, deep learning each application, deep learning or linear method can run on a single data set. But we have a lot of data set. We have a lot of applications. Each application generates data. We have a lot of departments. Each department have data, and we have a lot of companies. So all this data, you cannot just solve one by one. Get some feature, run a program, tune the things. One by one is not possible. So we want to have a brain. Yeah, Google have a brain. Yeah, we have a brain too. So we want to have a huge system, can take different data set, can maybe a large, huge different system.
So what's the relation with your big data set, with the data bridge product?
Yeah, that's something I want to mention. Maybe the data bridge can help you save a lot of money.
Yeah, exactly. So I think we pay a lot of effort to get all this data together and processing it. And so you can be used by a lot of guys. So we do not have a good solution yet. So I think
we love to share with you.
Yeah, exactly. So, and I think the second question is,
what kind of problem is important for industry, but also maybe addressed by the research community?
I guess the question will be what kind of question the industry would come for academic for help.
Yeah.
Nothing.
Yeah.
Okay. Or they really don't need our help.
No, it's not. It's not true. In fact, the company do things is quite different to academic because I half a year spent on CMU, half of my year spent on Baidu. So I know the gap here. For company, we over-engineer things. So because we want to get money, and here's the problem. Here's the data set you have. Yeah, you can put a lot of people to mine the data set, get some features, and use a lot of things. But that thing is not maybe not so elegant. Can be extended to something else. So I think for the academic, good thing that you make a good abstractions because you view a general view. So I think this is good or bad thing for a company. For the academic, the most question that I think there's different view from the big data.
Yeah,
we talk different things. we talk big data, but we talk different things. So we try a lot of, for example, I do give a lot of talk about what the problem we have. I think if it's really welcome for academic guys can come in to talk about what the problem we cause and what is the problem. Yeah, we have a lot of problems. So that is why I want to go CMU and why I want to go back companies. So it's a very detailed question, but for example, better optimization algorithms, more applications. So for company, what we most do is binary classification actually. So we do it for many years, but we have a lot of new applications. So yeah, we really care about.
Okay, so let's come to have some talk about this social meeting. So, so just now, James showed a very impressive video about your cyber physics social media lab. So could you tell us some difference between this cyber physical system and with your cyber physical social media? What's the difference? Or you just invented new notation about this?
Possibly, but I believe it will happen. Well, think it this way. When we have the first computer, right, after we know it can do computing works, and then we build more application, and then one thing we really care is the human-computer interaction.
Exactly.
That's how the multimedia things start to kick in. That's how we start to investigate what kind of basic interaction between operators or the user with the computer for the software functions. And then the computer have the network to connect each other, right? And then at that moment, we're just focusing on maybe searching for information. Right? That's how the search engine booming, right? And then we have the Web 1.0 because there's people distribute information, they create information, but limited to a certain amount of people, but there are a lot of users. And then when the technology evolved, right, software and hardware, we have Web 2.0, right? So now the networks of computers become social networks because we start to look for more than just information. We look for interaction, we look for communication in terms of we generate new information, live information people can actually share and connect people. So the same thing will happen again and again. Because of one thing didn't change, our social behavior. That's why we have the social computing. Imagine we have all these wearable devices, or our device start to allow us to interact with the environment. People pushing cyber physical system. Right now it's just the beginning, right? But once all this
so cyber CPS or cyber physical system is some kind of just a beginning.
Exactly.
Okay.
This is just like the first computer, right?
Okay.
Right. So once these things are ready or identified, for example, right now a few areas they already identify: medical, right? Transportation, right? Finance, entertainment, right? All these are highly social related to the people, right? So then it just comes back again. We are actually allow people to have a new emerging system to interact with the system differently. So we generate multimodal social signal that is able to capture by the network computer. So with that sense, actually we can have a better understanding about people behavior and their interests, right? And just like I give you an example, we have a mobile phone right now, we already know the location. What's next is, we can even know your health condition because of all these wearable devices, right? Maybe it's a time to have dinner, right? So because you're getting hungry. But for some people with those low glucose level, you can actually have an early alert. In the past, you need to alert. Okay, exactly. In the past, you need to track it, right? Now you have monitoring. Once all this multi-dimensional information getting more and more accurate or obvious, we are able to do a better job, just like you have a doctor all around you, right? And that's the reason I'm saying the cyber-physical social media, in fact, is already around when you start to see our mobile phone have so many interesting creative apps that can allow you to interact with the environment that already generate a different forms or dimension of social signal. And then people talking about the Internet of Things, integrating pretty much everything we can interact. Maybe in the future, my toaster will talk to my toilet bowl, right? So you never know, and all these people already talking smartphone. In fact, it's really integrated social media with our daily objects. So that's what I'm seeing, and that's why our lab is, on one side, we're doing analytics because the theory should be able to repeatedly applicable to different platforms, of course. When you have a new hardware platform, you have new limits and new ideas. But at the same time, we keep on building, pushing the possibility. That's why you see a very short sentence. We try to make what you see in the movie. We make futuristic realistic today, and then we will see what else will come up.
Okay, thank you. Thank you. Any questions here? Okay, please.
It's a question to James, actually. I also teach mobile programming in our university, and one of the aspects of teaching mobile programming is how to create apps. Yes. So the traditional computer science curriculums that teach you how to make this happen. You know, you have to learn HTML, you have to learn this SDK, you have to learn how to build it and how to debug it. But when you do mobile programming and the equation switches, so actually changes from how to program into what to program. So that comes to your domain.
Yeah. So change from how to program to what to program.
That's right.
Okay.
Now, from your lab experience, what have you learned that you can share with us? What to program? What app to make? Do you need a business model to get started?
They're just motivated by the movie.
I'm not sure about that. If the movie don't make money, nobody's gonna do it.
No.
Right? So do we need to actually have a business model behind app ideas to get it started?
Okay,
so that's my question.
Business model. So everything related to money.
Justin, this is a very challenging question. In fact, but it is valid, and also wood is something I'm experimenting with. Since I'm back to Asia 2 years ago, and then I do actually like all my undergrad course, I make all my students to do hands-on thing, right? Especially the undergraduate courses I teach is media, design, and technology. So the whole courses, the technology part is very obvious. You need to know how to do programming. You need to know data structure. You need to know system. But before that, actually, I move half of the course syllabus is about design. But the design, there's two different understanding of design. One is might be very easy to understand, the visual design, right? At least you make something look beautiful. One thing I can assure, if something looks ugly and complicated, the system, the app is not going to be flying.
Ugly and
complicated.
Okay.
Okay, it's not going to fly. The other bits actually is the design thinking. Actually, our university put this as a strategic area we're actually pushing. We actually have people from really the arts, like faculties from outside, not from our university, we invite over. We also have people actually pushing entrepreneurship, right? We try to make the student have an entrepreneurship mindset. And we also actually have our student actually taking courses in business school, trying to make them to able to know what actually make apps making sense to sustainable, right? What is the value to the user, right? And how to sustain like the apps or the system. Why so many free internet service are available, but they can still sustain? We make the student to understand that. So this is what we're trying to do. Try at least to make them to understand fundamentally what's the fundamental value of this app can change the world, right? It's a little bit aggressive, but we try to make them to think from the core value first. I think we have a conversation, right? How you can make people to really give up their privacy. I think it's more than that. How to make people really want to adopt a new technology. Fundamentally is the value. What's the value can change them to have like easier access to information highly relevant to their needs, and then make the whole efficiency much better. Look at it from fundamental, how to solve it, right? When they start to identify the value and then look for methodology, then that goes to the technology bits, or the programming, are you able to make it feasible? So most of the students, they will have the fear, wow, looks really almost mission impossible. Then we just show them movie. If the movie is possible, you you're possible to make it. So do it, right? So it's a learning process, right? So after they are able to build it, the next thing is maybe you can bring this to other big companies like Baidu or maybe Google or Apple, right? Or you can create the next Baidu, next Facebook, next Google, right? So that's how the entrepreneurs came in. And then hopefully there's some student. That's why our department is really interesting. We have an entrepreneurship stream in our electronic and computer engineering program. And then our university, I think just like MIT, they have 50K program. We have 1 million program. When you finish the course, if you want to start a company, write a business plan, work together with other team, and apply what you learn from the courses, come up with a business plan, and present, and we give the first 1 million to the student. And hopefully there are some other investor, I don't know, maybe Harvard, can contribute, right? So that's how we actually start to do in our university. We noticed that it's no longer just like in the past when I was still undergrad. It's no longer hello world. It's the other way around. It's really bringing your application to say hello to the world, real. We want them to think fundamentally. Especially we see a lot of stories coming from US. Even the high school kids can build apps, right? So we know that we cannot just teach them, okay, this is the command line you should put in order to run your programs. No, we go from the application and design thinking process. And then we show them what is the possible technology. You need to learn data structure for sure, but why? So we give them the reason why first. So this is something we are experimenting for now. I'm not sure whether we'll be really successful. Maybe after 2 more years, we can review this. Yeah.
But you can see the students are more motivated.
Yes.
Yeah, students more motivated to those apps.
Yeah, in fact, believe it or not, even I'm applying similar style in my PG course, in my graduate courses. In my graduate courses, I only, instead of like a midterm exam and final exam, I only have midterm exam on 1 page, okay? It's all open question, actually, it's dealing with grand challenge. But they are assessed by building real system. Okay, if you derive analytics, build it, and prove by experiment. So most of the paper we publish is actually backed up by real system experiments. And there's one student, when he finished the final project, he told me he don't want to present it. I said, why? You don't want to finish the course and get a grade? He said, actually, he just get the business plan to the university. Like we have the business plan competition. So he want to wait until then, and he really want to start a business based on what he learned from the graduate courses. So we start to see some students actually start to react like that. And whether at the end, this can be a more effective learning approach to make them to learn mobile apps programming development or big data system development. I think it's still early. We're trying to change the way we teach. At the same time, we want to make sure that at least when you write exam, you know how all this algorithm, you really know what you're doing. So we try to mix it right now, but hopefully after 2 more years, we can have a better.
Thank you for sharing.
Thank you.
Thank you.
So, there's time to have a question. Another challenge I think about here as well is that, we have lots of good algorithms, we have recommender systems, we have, so many things on big data, social computing, and talk about privacy. Users, right? Because they're the ones who are the consumers. They're going to be using applications that uses big data, social computing. So, has any of you addressed the user experience? Because one of the things that I know that from research or so is that you have to make it such that it is usable, that people will want to do it. I mean, do users want to have sensors on their bodies or so to monitor all this data? So the thing is that, there's this challenge, because the thing is that as researchers or as, analysts, you want to get more data. The more data you get, it's better, because you can do much more better prediction, much better recommendation or so. But for users, right, they don't want to sometimes give that amount of data. So how do you address that? And also as well, how do you make the user experience such that it's very, very easy to use, such that you don't need to have a PhD in order to actually run this application, or so that even your grandmother or so might be able to use it, right? If you want to benefit all of society. So have any of you addressed any of this type of user experience or so?
Okay, I guess, yeah.
Anyone?
Yeah, so actually my lab has a project funded by NSF looking especially for the usability problem of mobile apps. And so there are some alarming statistics. There are 100,000 more mobile health applications, but very few of them get downloaded for even 500 times. Right? And about two-thirds of the user will stop the applications only after they used it once. Right? So because
That's the once.
once they use it once, then they stop, they quit, they never use it again. Because either it's too complicated, it's hard to use, it's difficult to understand, right? So how do we build a good user experience, right? So there are some HCI related user centric design methodologies. Our approach, however, is from testing point of view. How do we test the mobile apps? So we have automated tools to test the usability. Basically whether the applications follow the guidelines for the mobile health or for whatever usability guidelines. And also, once it's deployed, actually being used by the actual users, our toolkits can capture every single interactions the user make with the apps. And with this, it's actually quite a lot of data, right? Think of a user touch, zoom in, zoom out, and also key inputs. And then after that, we analyze that data and trying to pinpoint where the users had problems. Right? So that's where the designers will get feedback to improve that process. So it's also a data-driven approach. But in general, usability is a hard problem. Right? And mostly if you want to design a successful app, you have to have a user experience expert involved in the whole development cycles. And test, right? So you have to do a lot of tests with your target population. So there is no sort of quick to fix rules. Right?
Okay, so the time flies. I can. Okay, look, one more question there. One more question there.
Before the question, let me just any more comments and follow Guanling stuff. And in that sense, I strongly encourage the collaboration between the academia side and industry side as well.
Yeah.
Because I'm mainly from this academia side, and we may not have the facilities or capabilities to develop so professional product that user would like to use and they say valuable. But industries like Baidu, they are the professional company doing so good, and they have a lot of good product that user would like to use because they have value. When user use it, therefore their data is also kept as well. So they are willing to use that. They are willing to give the data, but they have to have something that's valuable for them, right? So those things are difficult and often case for academia side to provide. So therefore, I think the collaboration between industries and academia are a very good choice.
Okay, thank you. And the question will be?
Maybe my question is very related to what Professor.
You closer to the mic.
Yeah.
And what I just consider is domain knowledge. Because if we have a kind of big data work, then we need big data scientists and domain expert together. So for example, suicide issues, we need to talk with the kind of counselor or medical doctor together to find the issues of the behavior of the patient. And the industry also has a different processes. So if we have big data, we need to find the kind of value. And if we have to provide service, we have to think about the process. But different industry has different process, and different domain has a different value. Then if we have different domain, then can we have any sustainable approach to use our big data analysis for any other kind of another industry field? So that is my kind of general question. So, but that is.
Okay, who do you expect to answer your question?
So I'm just.
I can start and follow up. Very good question, okay? And this is very realistic question and for data science. There's different programs in the United States and from different schools. they build up a kind of master program or on data science. So when you build up the data science program, that's different from traditional program in computer science or other domains and so on. They build up data science program and from the point of view of interdisciplinary research and collaboration and so on. So you're talking about a very important point is, well, it's I have the capability, learn the capabilities and to do the data analytics, but also I have to gain the domain knowledge because, if I already know the computer analytics and the skills, I don't know your domain knowledge, it's hard for me to address accurately and for the domain, right? So therefore, for the data science program right now, they have requirement. You're not only learning deep learning, machine learning, data mine, those kind of tools and so on, but also, and when they have kind of a capstone project and want to do something linked to your background, linked to your domains. So you not only become computing analytic aspect, but also become learning the knowledge of the domain expert. So by doing that, and students graduate from data science program, and we hope they have this kind of both capability to go back to their domain to solve the data science problem for the domain.
Okay, what's the opinion from Professor Chunming?
No comment.
No comment? Okay. Okay, so I guess we can continue the discussion during dinner. So thanks everyone, and the panel discussion is over. Thank you.
All right, thank you. Thank you all.